started with this. This is by no means a complete tutorial on how to run your CNC router using Fusion 360. It's just one example. You can see what I'm doing, and maybe you're doing something wrong and it's not working for you. And by me going through this process, maybe you're seeing something that I'm doing that is something that you're not doing. But this is Onshape. This is one of the programs I use. You can use Fusion 360 for design. I just don't particularly like Fusion 360. There's just a lot of little things that irk me. It's just the user interface. The program itself is very big, whereas the other one's very small. This is all web-based. I can run it out on my phone. I can use it at the computer. But here is the sketch that I used for drilling out all those holes, just little changes in X and Y as I went along. I knew the diameters just because I designed it and it was in my head already. But let's close this. So this is one of the things you can use. It's free and I like it. But I need to grab part 4 here. That's the bracket. So I'm going to double click on part 4 and we are going to export it. Okay, I'm going to give this a name that makes sense. Power feed motor bracket. Export it. Okay, I did it in SolidWorks because Fusion 360 is pretty good at accepting that. I've done other file types and it just really just kind of comes up all wonky in Fusion 360. So first step we're gonna have to do, we got to be in the design section, design, which is usually the first thing that shows up. But I got to click on upload. Okay, I got to select the file. There, that one. Okay, the window goes way down here. One of the things that I don't like about this, there's a lot of little itty bitty things on this that just irk me, that I can't stand. All right, so that is uploading. Another thing I don't like about it is if I just uploaded a file, why would I upload it without wanting to open it? So now I got to go to open. All right, I'm going to click the last one I've done. That's backwards 3 seconds ago. All right, let's click on that, open. It's going to take a little bit of time. While we're sitting here, this is by no means a complete tutorial. This will take hours and weeks just to explain everything that's in Fusion 360. It's complicated, and but if I'm going through all this and it works for me, and you're having problems with it and it's not working for you, maybe watching me do this is going to shed some light as to what you're doing wrong. But all right, so I'm going to hit save because if I don't, it's going to be irritating later. It's going to mandate that I save later. So let's go PF bracket and save. All right. Now what we're going to do, I'm going to try to orient this thing so that I can see it. I had it in Onshape in a, what is this? What do you want? Why? Okay, you can use this. Okay, there you go. All right. So, like I was saying before I got interrupted by my computer, I had it in Onshape as a weird, I had it on the front plane. And sometimes when you import it into Onshape, it keeps the orientation that it has in the program. But let's just do that for now. And now I'm going to go to design and click manufacturer. This is going to be for the actual manufacturing of the item. Okay, we got into this point where you want to do, before we do anything, we want to click setup. We want a new setup. And in this, we're going to have some sort of stuff going on. I don't like that, the way it's oriented. So hopefully I can change that. So let me see. We got to click our machine. We got to select a machine. If you're new to Fusion 360, you're going to have to create a machine, and there's lots of videos on that. That's how I did it. Mine has the y-axis on the table, X and Z on the head, on the gantry. So I hit select, and it has the right post processor. It said Gerbil. Okay, so we got that. And I'm not quite sure why it's being all goofy with this extra thing going on. And I don't really like that. So it's tilted at a 20-degree angle. So I'm going to go into here and transform this. I gotta see if there's a drawing with an axis I can use. Here we go, sketch 19. I'm going to go up to transform. I usually use this on my phone, so I'm not exactly sure where transform is on this menu. Transform, there we go. I'm going to click the part I want to transform. I'm going to click rotate axis, select the axis here. Oop. And which way did it go? Let's click on front here. Wrong way. So I'll type in -20. Okay. Hopefully this is going to reorient the part in Fusion 360. All right, so now I'm going to export this again, give it a new name. Export. PF mount bracket V.2. There we go. Export. Okay, now I'm going to go through this again. And I'm going to go to upload. See by my dock that something just happened. Select file. V.2. There we go. Open. Let's do the window. It keeps going down below where I can click it. Now I gotta go back and open. I click this again because apparently it doesn't like saving the last thing I preferred it to be. All right, so hopefully it's fixed now. PF mount bracket V.2. Save. All right, I'm gonna click this little orbit thing. I'm gonna move this so I can see what's going on. I want to look at this face. Why is it not editable? Make editable. Okay. So let's click manufacture. All right, so let's go to setup again, new setup. And I gotta select my machine again. Go to your local. You can see my post processor set as Gerbil, which is the router that I'm using. It runs on Gerbil. Okay. So what I want to do is select the origin that I want to do. I want to do this hole that's right in front of the big hole. Model box point. Maybe that'll let me do something. Nope. Model orientation. Selected point. Can I do a selected point? Here we go, maybe. There we go. So I want that to be right. And I got to pay attention to my axes now, because Z is going off to the left in a positive direction, which needs to be turned 90 degrees. So what I'm going to do, WCS origin, I'm going to select Z and X here. Okay, so I'm going to select my Z here. I'm going to click on select. My Z is going to be something that's vertical. Probably something like this, like that. There we go. Select our X axis. There we go. X to the left. I don't want to do that. I want to flip X axis so it's positive to the right. There we go. So X to the right is positive. Y away from me is positive. Z upwards is positive. So I'm going to click stock. I don't want to have any, it doesn't really matter because I'm using a point on here. So if I have extra, it doesn't really matter. Still going to cut the same amount, but I'll just set this for 0. Stock top offset. I want to make this is supposed to be 9 millimeters, but the stock I'm working with is like 9.2. So I'm going to put 0.2. So I want to cut all the way down through it. So I'm going to just pretend there's more material on this model. All right, and relative. I guess it doesn't matter how they think about it. Oh boy, dogs are getting growly. All right, stock width. Why is it 105 millimeters? I guess it is 105. All right, so it's a 0.2. How do I want to do this? How do I want to think about this? I'll do 0.2 on the bottom instead of on the top. I'll say 0. 0 on the top. I'll just make this a little bit longer. 0.3, just in case. At that point, the material is going to be so thin I could probably just break it off with my fingers, but okay, so that's correct. So I'm just going to go through here. Got my machine selected. I got all this stuff pointing in the right direction. And I'm going to hit OK. Okay. I don't need to drill all the holes in this program because you just saw me doing them all. It was just easier. Plus the CNC router is just a little, I haven't calibrated it well enough and I'm not sure if it can be, but over such a long distance, obviously the larger the piece that you're cutting, it increases the error that can happen, but you have a certain amount of steps per millimeter traveled. Now you get that set up a little better, which I will do probably off camera, but I trust my mill in my table on my mill to do all of these and get a much better result than I can with the CNC router that I have, anyways, at least. So we're going to need to do, basically we're just doing 2D operations. It's just going down, but essentially it's all 2D. So we're going to just do 2D operations here. So I'm going to do 2D adaptive clearing because I want to do these parts here that obviously this would be really difficult to do on a manual mill. So I'm going to click that one. Make sure you click the bottom, not the top. Otherwise it'll just move around the top and not cut anything. Okay, selected those. I got to click on a tool and I have my tool set. I have a 4 millimeter router bit that's really good with aluminum. So I'm going to choose that. 4 millimeter plus the features on here are set to be 2 millimeter radius or greater. And if I were to try to use a 6 millimeter on trying to do that, I can't make a 2 millimeter radius with a 6 millimeter end mill. So that's one thing to think about when you're designing something and choosing a tool. Okay, so you want to go through and just, I don't have the ability to use coolant on mine, so, and I can't turn it on anyways, even if I did. So when I'm first selecting the tool, I just want to pay attention to how I have things set up, because it seems to, when I do the next machining process, it's going to use these preferences for that tool. As far as the height goes, it kind of figures it all out on its own. If it spends a little bit of time going up and down and not cutting, I mean, I don't really care. It could be a little faster if you lowered them down, made them closer to the part, but it doesn't really matter. All right, so I'm just going to ignore this for now. Let's go to passes. I want to do multiple depths because my CNC router is not very good. Let's just say it's not very good. It's not like a $100,000 CNC machine. It has enough power to remove the material. It's just it's very flexy, and holding a piece rigid is really hard to do, even on my manual mill, which is way heavier. It's like 500 pounds, and this thing's only, I don't know, 15 maybe. But For me, at 300 feet or millimeters per second, I feel comfortable doing, I'm going to say, probably do a half millimeter, but I'm going to be a little conservative here. I'm going to do less because I don't care if it takes long. I'm not actually there to watch it happen. And I'm not doing 100 of these. So if it takes extra time, I don't care. So 0.25. If I didn't do that before I said 10 millimeters, it would have just tried to cut this entire thing out in one pass. And that is way too much for most machines. All right, so 0.25. The stock to leave is going to go in here. You got your radial stock, which is going to be the sides of these insets here, recesses. And the axial is going to be the bottom, the floor. So what I'm going to do is I'm going to make it so that I will leave 0.2 on the side, or 0.125. I'm going to do 5 thousandths. So 0.125 is a eighth of a millimeter, which transfers. There's 40 millimeters in it, or 40 thousandths approximately in a millimeter. So 40 divided by 8 is 5. And one of those is 0.125. So axial stock to leave, I'm going to leave a little bit more because when the bottom kind of gouges. And if I leave it at a little bit amount, I'm probably, once I try to do a finishing pass, it's probably not going to get rid of those. So I'm going to leave 0.25. That's 10 thousandths. I'm just going to hit OK. Okay, we'll see something pop up here on the left. It's generating the tool paths right now. It's thinking about it. In process. Okay. So that seems to be okay. It didn't show up as an error. If there was something wrong, you would see something red over here to let you know something was off. All right. So I'm going to do the same thing, except for now I'm going to take off the axial and radial amount that I left behind. So I'm going to do another 2D. Tool is already set up. And I'm going to click on the same things as I did before. All right. Heights, I'm going to ignore. Passes. Because there's only so much left, we could probably change our heights so that the starting depth of the cut is going to be that 0.2 off the bottom, whatever I set it to before. But I'm just going to leave multiple depths off. Oops, multiple depths off. I won't leave any stock because that's a material I'm cleaning up now with this process. And climb, I didn't mention that before. So like a drill press, your cutter is usually going clockwise from up above. And so what will happen if I go around this circle in a clockwise motion, the cutter will always be feeding into the work, into the new part. There's sort of problems with it, with doing like that, because you're removing material. So the material you're removing is going to get kind of sucked in between, get trapped in between the walls. It's going to be forcing those chips into the work that you're going to be cleaning up or cutting. And that's not as good. On a manual mill, you do this because you have the threads that move your table left and right. And if I do it the opposite way, sometimes the cutter will kind of push it along and it could cause it to jump and it gives you kind of crappy finish. But with climb, you're going the opposite direction. So it's cutting clockwise, but I'm moving in a counterclockwise motion. So it's ejecting those chips away from the cut. So when you're using a CNC router, you probably want to leave it in climb. There might be an occasion where you want to do that, but who knows? I haven't used it yet, especially with my crappy router. Let me see. Can I do some sort of finishing pass. Let me see. I don't know why. Maybe I want to do, I kind of like the look of the pattern of adaptive clearing. So I'll do that. Okay, so my maximum roughing depth is 10 millimeters. That means I'm allowing it to go as much as 10 millimeters on the first cut, which is going to be more than enough because I only got to do, this little shoulder is only 2.5 millimeters tall. So should be enough. 2.5 is less than 10, so I'll leave that. Let's just take a look at this one. You'll see the difference, what's happening in this first one versus the next one. I'm going to have to speed it up a little bit so it doesn't take forever. We're going to see it. It's probably going to bounce between pockets like that. Take a little bit more, take a little bit more, take a little bit more. This is going to be a long process. All right, so let's look at this one now. Because the depth of the cut is set much deeper, it's only going to do it in one, so I'm going to slow it down here. It went all the way down to the bottom right away, and we're only taking off that little bit that I left on the axial and radial stock to be left on the first operation. This adaptive clearing just makes it so that the load on the cutter is always the same, or pretty close to it. And it gives it a little bit more of an even finish. Okay, we don't need to watch this. Stop that. Let's exit. Okay. Now we are going to want to cut this piece out of this big piece of metal. So we want to do a 2D contour. There's also things you can think about. Let's just go through the options here. We got face. Like I said, just go through and just clean up the top. If I want, boring would be good for these holes here and here. It'll go down, and it's kind of like drilling. Obviously, you need an end mill that's smaller than the hole that you're going to want to make. And then you got circular, which would be good for following this big circumference, because I don't care if I don't need to remove the material in the middle. I just want to separate this chunk from the big chunk. So it's just going to follow this all the way around. You might be able to do that with 2D contour as well, but 2D contour is going to go around the sides for us. I have my tool selected. Cutting feed rate. I might slow this down. Well, no, I won't. 300's about good. Geometry, I want to be careful to select the bottom, okay? Don't select the top. It's going to be a closed chain, and that means that it's going to keep going around in a continuous motion. If I did an open chain, let's say I just wanted to leave like this section out here, where that's highlighted, I can do a open chain where I can just start and make my way partway around, have it pick it up, and then drop it down again and go around. But I'm not going to do that with this part. And then heights, I'm going to leave it alone like I did last time. Passes, this is going to be fairly important because I can't take that much off with my crappy router. So multiple depths. Let's do, I can't do 13.5 in one sitting. That's a lot of material to remove. So I'm going to do 0.5 like I did before. Yeah, maybe less. It doesn't do quite so well, my router anyways. I'll do 0.33. Okay, so 0.3 multiplied by, it's 9mm thick, so at 0.3, so it'd be 27 passes plus a little more. So let's do 0.35. Okay. Finishing, step down, 0.2, I don't need this. 0. Can I leave it at 0? No, I'll go back to 0.1. All right. And then I'm going to leave stock again because I want to finish up these edges. Axial stock I want to be 0. 0. because that's the floor. I just want to cut through all the way through. I'm using holes. My origin is set to one of the holes that I'm going to be using. These serve no function except for to hold this piece to the table. There's 3 holes on here, and you'll see it later when I have actually it set up in the machine. But my origin is one of these holes. So when it gets cut out, it'll still be held in place, and the outside will fall down away from it. If you're holding the part, in a vise or using an external feature, you obviously can't cut through the tools that you're using to hold this workpiece down. So you have to be careful of that. But once you get towards the end, there's almost nothing holding that piece in place anymore. So you got to be careful not to go all the way down through the material right away if you're doing it where you're holding it externally rather than internally like I'm doing. So it's one thing to pay attention to. I'm going to leave more than 0.1. I'll do 0.125. Oops, not that. 125. That's 1/8 of a millimeter, which translates roughly into 5 thousandths. Okay, let's hit OK. It's going to have quite a few passes going around. I'm not attempting to set any speed records with this. You see it's going in. There's not much to clear at all on these right here and over here and at the end. So on those parts, we will probably not hear a bunch of noise coming from the router. So now remember, we still have radial stock to take off. So I'm going to do like what I just did. I'm going to do another 2D contour, except I'm not going to have multiple depths set. I'm going to try to do it all at once because I'm only removing 1/8 of a millimeter radially along the whole piece. And I got to select our geometry. I got to make this so I can click the bottom. Let's go like that. All right. Heights, leave alone. Passes. I just want to make sure I have no stock left because that's the part I'm trying to remove now. Okay, let's click OK. Let's just take a look at that process. It's going to be a quick simulate. It's going to go down and go around once. Just like so. All right, so we can exit that simulation. I'm done. All right, so we have it all set up. So now what I need to do is send this. We need to create an NC file, .nc. So I'm going to go to Setup, double click, and then hit Post Process here. And I want to make sure that my post process is set to what my machine uses is a Gerbil. I'm going to give this a new name. I'll just call this PF bracket. I'm trying to use capital letters without using the caps lock. Sorry, slow typing that way. All right, it's in millimeters. Okay, post. And successfully posted. Okay, so I got that. Now I'm done with Fusion 360 for now. Let's get that out of there. Let's get this out of there. Now we have our universal G-code sender. This works in Windows and Mac, I do believe. For now, I'm not at my machine and it's not connected. But for now, let's open our NC file. Okay, NC files. I'm not sure if, nope, that's not it. Maybe it's in downloads. Nope. I didn't pay attention to where it was going. Where are you going? Fusion 360, NC programs. All right, that's where it's going. Don't like that file. I should have picked somewhere else for it to go. Let's just do that now. Post process. Yes. I didn't want to do that. Let's see, go backwards. I hit the wrong one. You gotta go on to setup and do it. Post process. There we go. And it gives you more options that way, apparently. Let's pick our folder. Okay, we want to go to desktop. I got an NC file folder there, which I was hoping it was going to be sent to post. All right. Now it should go to a location I can find. Desktop, NC files. Well, I forgot to change the name. It's back to 1001. It's going to take a little bit of time to open this up. And here it is. And this is why we use Fusion 360. Can you imagine writing all this down manually? I don't even know what this is. I know some basic G code, G90 and G94. I believe that's referring to absolute coordinate system, whatever. It's going to go something like that. G00 is move. Okay. All this stuff going on. And it's getting late in the night and it's raining and I'm ready for bed. So I will be attempting this tomorrow at the machine. And I will see you then.
All right, I got my plate. And what I need to do is get it in here. I find it's easiest to get these T-slots and everything on it first. Hopefully it's far enough from the wall you can actually get it in there. This is fiddly. I hate doing this. It's even worse trying to get the T-slot at the bottom in the right spot when you get a part up above it. All right, now it's in the right spot. All right. Now we need to get this lined up so that it's parallel with this face would need to be parallel with the x-axis. This face would need to be parallel with our y-axis. And what I have here is just a dial indicator. Let's see how tall this can get. I have the machine turned off for right now, so I can just turn these dials by hand. That makes it easy. When the machine is on, the stepper motors are locked in place. And you can still turn them, but it's harder. If you have a lathe, you do this quite a bit, or a mill, I'm sorry, not a lathe. You do this quite a bit for setting up your vise. So you get a lot of practice. It's increasing as I go this, or decreasing as it goes this way. So it needs to go this way so it increases. I'm not sure, you probably can't see it. And I'm just paying attention to what the value is doing. It's increasing as I'm going this way, so I need to keep going a little more. I need to bring this side over. I'm going to tighten down one of these bolts. Actually, no, it's just about right. I'm going to lock this down and then check it again here in a second. It's within 1/1000 of an inch, that whole span. So I'm going to lock this down, and that's good enough for right now. Oh, that was a dumb decision. All right, I made a bit of a mistake there. I could use that hole for alignment, and I forgot about it. So I have a 6mm end mill. You gotta make sure these are pushed in, and they like to stay locked in. They can be hard to get out. I'm gonna put this in upside down. And what I'm going to do is use a 6mm end mill to get my X and Y set to 0. I still have the machine off right now. All right, it's pretty close now. So I'm just going to do this and just turn the knob. If I feel resistance, I know that it's not in the right spot.
So I need to connect to my machine. It was just turned off. All right, X and Y are at 0 right now. I gotta unlock. Okay, I'm just gonna jog it back and forth a little bit here. Jog controller. Just
just going to do 1. Move X left 1, then back 1, Y 1, down 1. And then I'm going to see if I'm back over that hole again. It was just a little bit off. I'm going to go Z positive. Y needs to go a little bit positive. I will do 0.1. If you're going to an edge, you'd be doing this process of getting it to the edge, having it touch real close up, and then you have to factor in that you're half the tool width away from the edge, and then move it half that amount and then hit 0. So I'm just going to hit 0 on X, and I'm going to hit 0 on Y. Z is still up in the air. So, but it's too close to the workpiece right now, so I got to move it up. Move it up 20. And I need to put the 4mm end mill back in place. Let's get this 6 out of here. Let's get the 4 in there. I want as little stick out as possible to maintain a little bit more rigidity of this cutter. You don't want to be sticking it out as far as it can possibly go, because the longer it is, the flexier it becomes. But it has to be sticking out further than the workpiece is thick. So it's kind of a fine line. I know you can do it, call it nut. Believe in you. Come on, I know you can do it, call it nut. No, I think I know what the problem is. I gotta have to get this snapped in place. These things, you gotta push them in place, and I forgot about it. I'm filming and not paying attention. Okay, now I'll put that in. Alright, it should go a little bit easier. There we go. Alright, let's see how far this end mill can go in. I've pushed in all the way to the top. This is going to get sucked in a little bit as I tighten this. And let's get my wrenches out. Spinning. Okay, now I'm going to get, that's not enough. I need to get a little more Z height. It's wanting to make a sound. I don't know why. It's got a sound. Oh, I gotta put this nut back in place. It's got a sound. Where did I place that nut? It's underneath the machine, or it's a bolt, not a nut. Hopefully that T-nut's in the right spot. Listen to the frequency of that sound. I gotta make sure this is tightened well. Do not want the workpiece moving. This Allen head is pretty sad. Throw that away when I'm done with this. All right. That's nice. All right, I'm going to move the Z probe over here because that nut's now in the way. Now I need lots of Y action backwards. Negative Y. Now I must do the Z probe. Let's go to probage. I'm just going to go to settings to show you. And probe module, we are going to do Z. That plate is 19.3. I've already done this before. Probe module Z. And now you will see it on my other camera. It's going to go down. It's doing so slowly right now. Why is there an alarm? Oh, I see. Toolbox. Unlock. It was too far away from the Z probe. Let's do that again.
I have never done that before. Okay, it hit. Now it's going to do it much slower. Just like so. Okay, now I need to import my NC file. Open. I got my bracket v2.nc. Let's open that. Might take a little bit of time. And there it is. Okay, now hold on to your butts. It's going to get started. I'm going to hit send. I just turned on the air pump. I'm sorry, I got to talk over the motor now. The air pump is blowing air and evacuating the chips away, which is really useful for this. Okay, it's time to get this out. You can see it didn't make it quite all the way through, but it's very, very thin. I should be able to just take a file to all the edges once I snap this off. You noticed that it's now backwards in here. That's because I ran into a stop at the first pass of doing this outline here, and I had to flip it around given the rails. It was just like a millimeter or two outside its boundaries, and it just stopped. So I had to carefully get it back in place and re-zero it, and it turned out you can't even tell. So I got it back in place pretty well. And just like so.